Hi guys, welcome to the video. As always, AQA exam board, A-level computer science. And today we're going to be looking at tree traversal algorithms. In the top right hand corner, you'll see a reference to the official AQA spec where you've got both the content and the additional information present within this video, all of which will be covered. And let's jump straight in. So just to begin with some background, abstract data structures, if you've looked at those videos already, you'll have some awareness of what these are. But a tree is a connected, undirected graph, essentially, which features no cycles. That is, it doesn't have more than one connection going to any node. This does not need to have a root node either. Connected implies it is possible to reach one node from any other. No cycles implies that it is not possible to find a path in the tree which returns to the start node without traversing an edge twice. Now, we're going to look at two examples. We're going to look at both an example of a tree and a non-example. On the left-hand side, you can see what we're calling an example. That is because it doesn't have any cycles present within the graph itself, thus being a tree. Whereas on the right-hand side, you've got what we would consider to be a graph and not a tree. And that is because it's got an extended branch that goes between, or an edge, between B and E, thus creating a cycle within the graph. So that there itself, we cannot categorize as being a tree. Now, a binary tree is a specific type of tree. It's called a rooted tree, in which one node has a maximum of 2 children. And I'm going to give you an example here. First of all, with a set of rules of how we can go about placing values into a binary tree, and the order with which you do that based on the order with which you're given the values. And I'm going to give you an example of the following list of numbers: 18, 9, 5, 13, 23, 20, 15, 6, 31, and 26. And the first thing you need to do is place the first item at the root of the tree. For each item in the list, then visit the root, which becomes the current node. Branch left if the item is less than the node, branch right if the item is greater than the node, and continue until a leaf node is reached. Now, on the next slide, what you're going to see is the implementation of this. And that is what you should get if you follow those steps carefully. That is the completed placing of the values inside of a binary tree in accordance with those steps. And having done that, there are now a few ways that you can go about traversing the binary tree. And there are three main ways. The first one is preorder traversal. The second one is in order. The third is post order. And essentially, these different traversal methods dictate the way in which we read values from the tree itself. And I've said here, these names have been applied with relevance to the time at which the roots of each subtree are visited, i.e. whether it's before, between, or after both branches have been traversed. And you're going to see some examples of that. Now, in preorder traversal, we are essentially reading values from the tree itself every time we pass the left-hand side of any node. So you'll notice in this example that we begin by reading 18 because we're going down the left-hand side initially of this tree. We're then going to pass 9, 5, 6. We then go past 13, before then 15. We then go past 23, 20, and round to 31, and finally ending on 26. If I move on again, you'll notice that in order, we're now talking about a very similar setup, but instead we're talking about something whereby we've got now the opportunity of reading the central point of those nodes. So if we start off here, we don't read 18 or 9 central point. We're not underneath that by the sort of the starting point of this particular traversal. We only pass the left-hand side of those nodes. Before then going under the bottom of 5, the bottom of 6, the bottom of 9, the bottom of 13, 15, so on and so forth, round now under 18, then 20, 23, 26, and finally finishing on 31. You'll notice that in all three of these examples, the arrows are always in the same place and they're always facing the same direction. You always traverse the same path as such when reading values from a tree, but it's where you then record them and note as being traversed in accordance with whether you're looking at pre-order, in order, or post-order. Now, what you might want to do now is actually pause this video and have a go at now trying to read the values in a post-order way. We've read them from the left-hand side, passing point. We've read them from the middle section. We're now going to be reading them from the right-hand side. So if you'd like to pause and give this a go, please do. Otherwise, the solution is as follows. The first one we would read from is 6, then 5, 15, 13, 9, before then 20, 26, 31, 23, and finally 18 this time around.